It's recording. Exercise 2B is called parallel line properties. Now, let's start off. When we say parallel, what does parallel mean? Hands up. Yes, Ashwin.
A line that does not intersect with each other.
Very good. So they run alongside with each other, which means they run at a certain angle, let's say this way, and we draw an arrow to say it's going in a certain direction. That means that for it to be parallel, the other line has to also be running in the same direction in the same angle as well. That's the only way the two lines will never intersect. It's kind of like your tables at the moment. They were cut parallel to each other so they'd never just curve in. Otherwise, one will look more narrow and one will look a bit wider. So for it to be equally the same distance all the way, they have to be going the same direction. That's what we mean by parallel. How do we show that it's parallel? The two arrows. If you don't draw the two arrows, it means that they're not parallel. Okay? Now, today's lesson, you're going to learn 4 properties. When you have parallel lines, there are 4 key properties and they have 4 names. Okay? First one already filled out is called corresponding angles. The other one, make sure to copy this down, okay? So whatever you guys are doing on your laptops, can you please make sure to be looking at the screen as well? Or at least copying the notes. Corresponding angles. The other one is called co-interior. So copy this one down. It's called co-interior angles. Your third one is called alternate angles. And then your fourth one, which is what we learned yesterday, starting with V, vertically opposite. Very good. So you were partly correct there. So vertically opposite. These are the 4 properties. So the first part of our session today, I'm going to give you later about 7 minutes to do question 1, and then we'll check out our answers. But the first step is underneath, I created a table because I found that over my years, when I teach it in this way, a lot of students are then able to remember which of the 4 the properties are. So in this table, I've already set it up for you. There are 2 columns. One's called same column and the other one's called different, right? Now, what do I mean by same and different? This is what I mean. Same, under the same column, there is what we call a transversal line. So when you do when you did your readiness task, there was this line or a name called transversal line. Write that one down. What that line basically means is, or the name that's given to this line is the line that cuts the parallel lines. That's it. It's a line that cuts the parallel lines. We call that a transversal line. What's nice is when you use a transversal line and it cuts the parallel lines, you can get 2 different sides. In this case, you get the left side, so the left half, and then you have the right half. True? Whereas in the example above, when I drew the parallel lines here, if I had a transversal line that was like this instead, if it cuts like that, well then you have a top half and a bottom half. True? Okay, so top half, bottom half, left half, right half. Now, the reason why I have same and different is to help you organize which types you're going to be. And the easiest way to remember it is, if the 2 angles that you have are on the same side of the transversal line. So here's an example. If I have an angle here, and I call that angle A. Actually, I'll give it a number just to make it easier for you. Let's call that 30 degrees because it's roughly an acute angle. So let's call it 30. Then that's on the left side of the transversal line, right? If I want it to be either this, see what it is called, it has to be on the left side as well. So another angle. I'm going to do another angle and I'm going to call it B now, or B. See these 2 angles? They're both on the left side. Okay, so that's why they're on the same side. They're both on the left side, so it's the same thing. If they're both on the left side, so same side, so underneath, I want you to write this down. So if they're both on the same side, which they are, okay, and then the next property is if it's top with, and I want you to fill this in, it says top and bottom with bottom. What does this mean? What I'm trying to help you remember or memorize is if the angle is on the bottom or top of the first line, and then on the second line, if the second angle is also the same, it's on the bottom of the second line. See how it's bottom? So So this one's on the bottom of the first line. This is bottom of the second line. If that is true, it is called corresponding. So that's your first one. Okay, so it only works if it's top with top, bottom with bottom, but they both have to be on the same side. So I'll give you some more examples, okay? So here's another example. What's another corresponding angle? Let's say I pick the one over here now. So I'm going to pick the right side. So this line and this blue line makes this angle. So that green line and that blue line creates this angle when I move them, right? That there, is that on the right side or on the left side of the transversal line? It is on the right side. Now, if I want a corresponding angle, okay, I need it to also be on the right. Notice, is this on the top of the first line or is it on the bottom of the first line? It is on the top. So if I want it to be corresponding, then the second line that I need, or the second angle I need, it needs to also be on the top. So this is top. This needs to be top. Then these two angles now, they're both on the right side. They're both top with top. That's called corresponding, because the definition of corresponding means like whatever you do, the other one does as well. It corresponds with each other, right? So angle A and angle B is corresponding. Okay, let's do another one. Let's do a color orange. So I can pick this bottom corner here. So I do it in orange. That angle there that's created by the green line and the blue line, that's an obtuse angle there. This obtuse angle is on the right side. So it's on the right side. And it's on the bottom or top? Bottom. So this is the bottom. So if I want an angle to be corresponding to it, it needs to be on the bottom as well of the second line. So this is bottom. See that? So they're both on the right side and they're both on the bottom. Then it's called corresponding. Cool? Now, if they are corresponding, why do we need to know if it's corresponding or not? It's because we know when they're corresponding, the angles are equal. It means that when I said this is 30 degrees, that means that B, this is also 30 degrees. If this obtuse angle was 150, then this angle down here must be 150 as well. That's why we like corresponding. Okay, so that's a property. That's the first one. So why did I put it under the same column? It's because both angles have to be on the same side. So that's the first question you're always going to ask. You're going to ask, are the angles, the two angles that you're looking at, are they on the same side? Once they are, then you have only two options. It's either corresponding or the other one also starts with C as well because they have the same letter. So corresponding, and what's the other one? Co-interior. So there's only two. There's only two types. There's only two types. So when you ask the first question, you say, are the two angles on the same side of the transversal line? It narrows it down from 4 to 2 options. Co-interior. Let's do this example now. So I'm going to draw a transversal line again. So here's my transversal line. It cuts it. It makes a right side and a left side. So co-interior is under the column same. Because it's under the column of same, that means the two angles have to be on the same side. Now, co-interior is actually the second easiest one to remember. Interior. What does interior mean? Inside. So here's your parallel lines, right? They need to be on the same side, but also they have to be inside the parallel lines. So here are the angles that are co-interior. The green line and the blue line, that's inside the parallel line. See how it's inside the parallel lines? So these are my two lines. That's inside. It's on the right side. So if I want the other angle to be co-interior, it needs to also be on the right side, but it also has to be inside the parallel line. So this is the only other point that it can be. These two angles, so if I called this A and I called this B, these two angles are called co-interior because they're both on the right side and they're both inside the parallel line. So I'm going to write inside to help you remember here. So inside, inside. There's also another set of co-interiors. So you can see you've got the right side, well then you also have the left side. That means these two, this angle here and this angle here, they're both on the left and they're both inside the parallel lines. These are called co-interior. So if I called it C and D are co-interior, A and B are co-interior. What are the things to help you remember? They need to be on the same side. So both of them are on the right, both of them on the left. And they both have to be inside the parallel lines. That's how you know it's co-interior. Now, co-interior is the special one out of all four. If they are co-interior, A does not equal to B. Now, logically, you can see that. One's obtuse angle and one's an acute angle, so obviously they can't equal. But they are supplementary. What does supplementary mean again? Yes, Will.
They add up to 90?
No. 180, very good. What's the one that's add up to 90 called? Complementary. Okay, so in this case, A and B must add up to 180. So that's the special one. That's the only one out of the four that has to be supplementary. The rest is always equal. Okay, so A and B, you can tell because one's obtuse and one's acute. It can't be equal. They actually add up to 180. Okay, so that's the two properties there. So if I zoom out, can you see why I put it under the column same? So I've taught this for 13 years now, and every year I was able to get students to memorize these four. It's very easy because once you got same, you know it's either co-interior or corresponding. They both start with C, and that means the two angles have to be on the same side of the transversal line. Very easy, yeah? Whereas if they are different, if the angles are on different sides of the transversal line, so let's go to the top right corner. If it's under the different column, that means the angles, the two angles you're looking at, they're not on the same side. This one is called alternate. Alternate angles. So I'm going to draw the transversal line again. So here's my transversal line. He cuts it. Here's a right side. Here's a left side. Now for it to be alternate, they must be first on different sides. Okay, so one has to be on the left, one has to be on the right. So if I draw an angle, say I draw this one, that angle's on the right side. True? So that's right. Now if I want it to be alternate, it can't be on the right side anymore. The other angle has to be somewhere on the left. Now for it to be an alternate angle, here I wrote some notes for you. Outside with outside, and inside with inside. Now, if you look at this angle that I drew for the first one, so angle A, is this inside or outside of the parallel lines? Inside. So this is inside. So that means the other angle must also be inside. Now, over here, that's on opposite sides. These two angles are alternate. Now, one common mistake that students do is they write B here. Why is this B and A not alternate? Because it's on the left side, they're on opposite sides, and we said they don't both need to be inside, so that's true. But why is B and A clearly not alternate? What is it though? They're supplementary. Can you see this is a straight line? If you add B and A together, it's actually a half a circle. So this is called supplementary, not alternate. That must be alternate. So these two will equal, and also if you look at the angles, they're clearly different as well. That one's an acute angle and that's an obtuse angle, so how can they be the same, right? So alternate angles are the same. This is obtuse, that's obtuse. These two are alternate. That one is not alternate. This is supplementary. Okay, so be careful with that. That's a very common mistake students tend to make. So A and A, so that's inside, inside, and they're both on different sides. One's on the right, one's on the left. Let's pick another one that's alternate. I can do up here. Okay, let's call that C. So angle C, can you see how that is now on the left side? So that means I need the second angle to be on the on the right side. So one's on the left, the other one needs to be on the right. But the first question is this on the inside or the outside of the parallel lines? Outside. So this is outside, and we said outside with outside, inside with inside. So if I want C to be altered with another angle, the other angle has to be, yes, Elliot? Yes, very good. Down right here. Is this where you were thinking? Very good. So C and D, that's on the outside, that's on the outside, one's on left, one's on right. That's called alternate. Okay? So there's a proper name for it. They usually call it alternate interior, alternate exterior, but a lot of students tend to forget that, so we normally just call it alternate. Okay, but the proper name for it is alternate interior, alternate exterior. Okay? All right. So far, so good. Now, if they're alternate, then that means angles A equals angles B, and angle C equals angles D, which makes sense. Obtuse with obtuse, and A with B, that's also obtuse as well. What you also notice is, do you notice this from yesterday? See that intersection? C and A are what? What are they called? What's C and A? They're obtuse, but what's special about this? There's something special about C and A at the moment. Anyone know? Because that links to the next exercise, the next property. Yeah, they're both vertically opposite. Remember yesterday how I showed you, I said, when you have an intersection of two lines, the opposite angles are the same, and the other double sides are the same. That's exactly the point here. We've got two lines that intersect. They're vertically opposite one another. One's on the right, one's on the left, and they're both directly opposite to one another, right at the intersection. So, it's interesting. That's why C actually equals A, and A equals B, and B actually equals D. It's actually all equal. So if this was 150 degrees, this would be 150, this would be 150, and this will be 150 as well. Okay, because I'm using two properties there, alternate and vertically opposite. So vertically opposite is what you guys learned yesterday. This is actually the easiest one to remember. So I'm going to draw the transversal line again, and I'm going to repeat what we just had before. So this is your last one. Vertically opposite is the easiest one to find first. Co-interior is your second one. Then your top two are very similar. Okay, so vertically opposite literally is where the intersections are. So they both have to be on different sides. It's where both lines intersect. Now, can you see the two lines? They intersect twice. Where do they intersect? Once here. They intersect once there. And they also intersect another point over here. So there are two areas that are vertically opposite. So opposite angles are equal. So if I wrote down what I wrote before, we had angle C was actually equal to angle A. C and A are actually equal to each other. And then angle A, which we already know is equal to angle B because of alternate, inside, inside. But then angle B was actually equal to angle D, the one that Elliot got right. Okay? So you can see C and D, outside, outside, they're alternate. But what's interesting is C and A is vertically opposite and B and D is vertically opposite. Okay? So vertically opposite angles are equal. So now you think about it, you always ask yourself, are the two angles you're looking at, are they on the same side? Because if they're different, there's only two options. It's either alternate or vertically opposite. If they're on the same side of the transversal line, it's only co-interior or corresponding. Co-interior is the easiest one to remember because they're both inside the parallel lines. And vertically opposite is one of the easiest ones to remember too. Find the intersection. Directly opposite is equal. That's how you start to distinguish which one is co-interior, which one's vertically opposite. There will be questions where it's neither. Not any of these four. So it means that you can't use the property. So it means the angles aren't the same. This is the only one that is supplementary. Okay, so co-interior is the only one that's supplementary. We good? So the notes are in front of you. What I'm going to get you to do now is just find a little spare side of your paper, maybe on the top right corner here. Okay, I'm going to show you question 1 of exercise 2B. And you're going to write ABC. There's 6 questions. You're going to write which type it is. Okay, so here we go. Here is question 1 of 2B. I'm going to give you 7 minutes to identify A, B, C, D, E, F. Is it neither, alternate, corresponding, co-interior, or vertically opposite? Which one is it? Okay, so A, B, C, D, E, F. You've got 7 minutes. It's 10:44. Let's go. I'm going to pause the video. I'm going to resume. All right, question 1A. What did you get? Let's go with Hauschwan. What'd you get? Close, but no. It is either alternate or vertically opposite. So you were 50-50 there. This is not vertically opposite because this is one intersection. So A is on one of the intersection and B is on a separate intersection. So they're not vertical opposite. If B was here, you were correct. So they have to be in the same intersection. They can't be on different ones. Okay? So If it's not vertically opposite, it is what, Ava? It is alternate. And how do you know? Again, one's on the left, one's on the right, but this one's inside, and this is also inside. So remember, inside with inside, outside with outside. Next one, B. What'd you get for B? Let's go, Tom. Corresponding. That is correct. Again, both of them are on the right side, and this is on the top. This is also on the top. Okay, so top of the first line, top of the second line, so it's corresponding. Give yourselves a tick if you got that right. Actually, hands up if you got it right. Good. Good start. Next one. C, what did you get? Let's go with Wilbur. What type of angle is this? What'd you get? Oh, you don't know? Okay, Wendy. You don't know? Let's go with Elizabeth. What type of angle is this? You got your 4. Co-interior is correct. And how do you know? Again, they're both on the left side, so left and left. But notice they're both inside the parallel lines. Because they're both inside, they are co-interior. Very good. Next one. Let's go with D. Is a bit different because they swapped the direction around. But same idea. Find the transversal line. Here we go. Who's got this one? Who wants to have a go? Someone else. Lucas? Corresponding. Let's see if this is correct. Corresponding. And yes, it is because both of them on the bottom of the transversal line. So it's on the same side. This is on the inside. This is not on the inside. So it can't be co-interior. This is on the right side of the first line. And this is also on the right side of this second line. So hence, it is corresponding. So whatever's happening to one, the other one does the same. So it is corresponding. Well done. Let's go with E. What'd you get for E? Let's go with Elliot. But if you were to do it now. Co-interior is correct. Very good. Co-interior because, again, transversal line. Inside the parallel line, they're both on the same side, so it must be co-interior. Last one, F. What did you get for F? Can I please have, let's go with man. Vertically opposite is not correct because that's 50-50 again. Again, find the intersection. See how that's one intersection? That's 2 intersections. They're on separate intersections at the moment. They have to be on the same intersection. So it's not vertically opposite, but it must then be alternate. And how do we know? This is on the inside of the parallel lines. This is also on the inside of the parallel lines. So they must be alternate. How's that so far? Very good. That's out of 6. Hands up if you got at least 1 correct. Okay, good. So no one got 0. Good. Hands up if you got 2 correct. All right, that's a good start. And hands up if you got 50% correct, which is half. 3 out of 6. All right, good. Excellent. Now, let's go back to our notes. Now that you can identify, flip over the next page. We're going to do the problems together. So you have to first be able to identify, and then you can then solve. Okay, so here we go. I'm zooming into the example 2A. Can you see here? 70 and B. I look at 2 angles. You pick 2 angles to look at. I look at 70 and B, and I can already say B is 70 degrees. Why? What do I know? Tom? Vertically opposite. So man and Haushan, can you see how these are on the one axis intersection? So that is when you have vertically opposite. So that's an example of it. Okay, so here, these 2 are on the one intersection. So yes, this is vertically opposite. So that's why B is equal to 70 as well. Very good. Next one. Now that I got B is 70, you can either find A or you can find C. Now what's B and C? B and C are, hands up. What's B and C? What type of property? Co-interior. Now what do we know about co-interior again? The angles must be not equal. Supplementary. Can you see how this is obtuse angle and that's an acute? They can't be equal. You always got to look at the diagram. So here they have to be supplementary, means they have to add up to 180, not 90. So adding up to 180, what must C be? 110. Very good. 110 plus 70 gives you 180. And then there's two ways to find A. But we can already see B and A is a type of property. What's B and A? B and A on different sides. So remember, this is on the left, this is on the right. Elizabeth. A doesn't equal 70, but why? What Elizabeth just said is the second method. Can you see? This is a straight line. C is 110. So adding on the extra A will give you 180. It's supplementary. So Elizabeth went with 110 and A. C and A are supplementary. But B and A is also 70 because they're alternate. Can you see they're both inside the parallel lines and they're both on different sides of the parallel line. So hence A and B are also equal to 70. So you've got two different ways to get there. Okay, so that's what I mean. If you can't identify, you can't solve. You have to be able to identify them correctly, then you can solve them correctly. Cool? That's what today's lesson is. I don't expect you to be able to do all of 2B by the end of the weekend. Remember, it's only 2A. So I would say if you haven't finished 2A, go back to 2A. This is your time, your session to work on exercise 2A. You can work on this next week. Now, we don't have Monday because it's a long weekend, so you don't have the half session. But we have the next session to work on half of it, half of Wednesday, and then the other half I'll start showing you.
Should we take these?
Yeah, if you want. That was just a spare sheet that I gave to my students.
Oh, you're taking them. You're not together.
Oh, yeah, it's Friday. Oh, man, that's a pain. So I won't see you for another week after today. That's right. I see the other class on Wednesday. Yeah, I see you Thursday. Athletics. That's right. We did talk about it yesterday. Thanks for reminding me. So only one exercise then. Exercise 2A.
My one doesn't work, so you're not going to be able to send it.
Oh, that's all right. Well, then I'll take a photo on Friday.
Kyle and I are losing one, so question 5A.
All right, I'm going to stop.